Oh, hello everybody. I'd like to welcome you to our first seminar of a series of seminars which is coming now. What we like to give you a little bit the news of instrumentation. We like to show you our basket, and that's the slogan, choose according to your needs. So what we like to give you is an overview about all the new products in our basket, and let's say the new innovations for in this seminar for level and pressure, and in the upcoming seminars then for flow, for temperature, and for the analytical instrumentations. We are happy to have you all here. We hope we can give you a little bit insight about our basket, specialized for the food and beverage industry. Yeah, before we start, let's introduce the tooling a little bit. You can increase and decrease the webcam window at the left-hand side. As well, we did already upload the presentation as a PDF. So if you are interested in this presentation, please use the download function here on the right side. Whenever you have questions, then please write the questions in the comment box or in the question box, in the chat box here. And we will then, at the very end, we will have a Q&A session, where we then going through all the questions. In case we cannot answer all the questions, don't worry about that. Then we will go in contact with you afterwards via email. So we will take care that all the questions will be answered at the end of this session. And then, of course, we are doing a recording of this session. So whenever you like to see this seminar again, or when you see the need to share it maybe with some colleagues in your factories which are not able to participate today, so you can see this seminar as well later on from the recordings. All right, who are the speakers for today? That's first me, Matthias Schützeberg. I am the Industry Development Manager for Food and Beverage at the Endress+Hauser Group Services AG here in Switzerland, Rheinach, doing this since 33 years. And I am, for this seminar, just the moderator. I hope I can manage the technique a little bit. The speaker is Ralf Knall. He is from the Product Center for Level and Pressure. And Ralf, you can start right away with your introduction. Thank you. The floor is yours.
Thank you, Matthias, for the introduction, and welcome also from my side, ladies and gentlemen, all over I would say it's more around the Western Hemisphere, so in the American continent and maybe in Africa and in Europe. We have some people here on board. So, as mentioned, my name is Ralf Knall. I'm Industry Manager for Food and Beverage at the Production Center, or let's call it the Competence Center for Level and Pressure in Germany. Here on the map you can see where I'm situated. This is our factory in the southwestern part of Germany, right in the corner between the three countries, France, Switzerland, and Germany. And this is where Endress+Hauser was founded in 1953. And here we have our competence center for level and pressure, where we develop and produce level and pressure devices. All in all, we have 1,700 employees on this campus on a production and office area of around about 100,000 square meters. And we are not producing only in Germany. We also have associated production sites all over the globe, starting from Japan over China, India, USA, and also in Brazil. We have entities which produce devices to serve to local markets. Today, we want to focus on the food and beverage industry. So I will give you an overview about the typical products that we use in hygienic applications. So the focus is clearly on hygienic applications. And on this slide, you can see the portfolio that we offer for pressure measurement. So it starts with the fundamental segment for basic applications. Here on the left side, we have the products from the so-called fundamental segment. For these products, simplicity and the ease of use is most important. We also offer IO-link connectivity for these transmitters to integrate it into new digital controls. Then we have the lean segment. Here we offer a modular design with various sensor technologies, different electronics and housing concepts, and they enable the perfect fit in most of the applications in the food and beverage industry. And also for this product segment, we will offer in a few weeks from now IO-link connectivity. And the premium segment is here on the right side. This comes with a double chamber housing and of course further improved performance in terms of measurement and also in terms of safety features. A detailed overview will follow in the next slides later in the presentation. So also for point level, we have different sensor technologies and different product segments, starting from the very basic devices based on the capacitance principle up to the vibration fork technology, which is very well known in the market, and also other technologies for heavy duty applications like the liquid cup FTI 51, which is used especially in high temperature and high pressure applications. Also for point level, I will give you a little overview later on in a bit more detail. But let's start with the continuous measurement. So most common technology in food and beverage for level measurement is currently the hydrostatic level measurement. And by the use of a basically pressure sensor at the bottom of the tank, we can measure the weight of the hydrostatic water column and refer this to the liquid level inside the tank. So technology is very easy to understand, easy to install, and proven in use for several decades already. So still state of the art in the food and beverage industry, and also the measurement can be realized at a reasonable price. But besides hydrostatic level measurement, we also offer a comprehensive portfolio of other technologies, like the capacitive technology, the guided wave radar technology, and also the free space radar. All of these technologies have their pros and cons. So capacitance probes, for example, they often are used in applications where reliable measurement in fast filling and draining applications is required. So typically narrow tanks, small tanks, filling processes. So here the liquid cup sensor has its advantages because it's a really fast measurement technology. Also, if foam is present in the application, it does not affect the measurement, so it still gives you a reliable reading of the real level in the process. Another advantage of the Endress+Hauser solution for the capacitance probe is that it comes pre-calibrated from the factory, so you can install it and commission it without any further adjustment. So it's a real plug-and-play solution. However, capacitance measurement cannot be used anymore if the dielectric constant of the measured media is changing. So if you have different types of media inside the process which have different dielectric constant, this has an effect on the measurement of the capacitive device, and therefore you would have to readjust the instrument, which is of course not always possible. Also, hydrostatic level measurement has a disadvantage because it is dependent on the medium density. So changing densities of a hydrostatic level transmitter also affect the accuracy in the end. In such cases, you can rely then on the high accurate radar technology. So a perfect solution, of course, is the free space radar, the micropilot, since it's a non-contact technology, so you don't have to take care of hygienic design, for example, cleanability, also build up, and such kind of effects are minimized. With the new devices based on the 80 gigahertz measurement frequency, you can also operate these devices in very small applications, in narrow tanks, and also in applications where you don't have much space for a nozzle. So this fits into a 3/4 inch nozzle easily. Nevertheless, when it comes to extreme turbulences, when it comes to strong foam formation, then the the free space radar technology as it is at the limit. Then the guided wave radar will give you an additional measurement safety. So it's more reliable in such conditions, especially if foam is present. The guided wave radar performs much more reliable. So both of these radar technologies, they are available with a Bluetooth module. So this means you can set up the device via Bluetooth. It's not necessary to connect with a hard communicator, for example. You can do this easily via smartphone and our free of charge Bluetooth Smart Blue app. Also, when we talk about raw material applications, bulk applications, edible oils, etc., radar technology is state of the art. So here, typically no other technologies are used anymore, neither capacitance nor hydrostatic pressure. So then it's a clear radar type of sensor used. But we don't want to focus too much on these applications because typically they're not installed in a hygienic way. So it's more like the flanges and thread connections. So back to the hygienic applications. I would like to start with a typical application from the beverage industries, and especially when cold media like milk or beer or soft drinks are processed, and this is typically done in a cold state. This cold process often leads to challenges for hydrostatic level sensors. So if the process is colder than the ambient temperature, condensate will form on all the equipment that is not insulated. And typically a pressure transmitter is not insulated. As you can see here on the left picture, it's installed here in a beer or in a milk line, and you see the condensation all over the place. And it's not just the humidity itself on the surface, but also humidity may penetrate inside the sensor. So, for example, if lids are not tightened properly or cable glands are loose. So also the so-called pumping effect is quite a critical, let's say, obstacle in the process. This typically occurs when you have changing process temperatures, like during the processing sequence, and after that you start the cleaning cycle, and the temperatures rise then from close to 0 up to maybe 80 or 90 degrees. And these temperature changes, they cause contraction and expansion of the air inside the instrument. And this so-called pumping effect leads also to the replacement of air, of course. And if the air is saturated with water or with dust, it may settle inside the device. You probably also know this picture here. You can see Heavy washdown, of course, also occurs in many applications, in many plants where the devices are cleaned together with the whole equipment. And also here we have to make sure that everything is tight. So typically our instruments are IP68 or IP69 certified and designed. Yeah, but especially when we talk about hydrostatic level measurement, and here pressure transmitters for gauge pressure measurement are used, and they face a very high sensitivity to the water ingress. If moisture penetrates into the breathing system of such a sensor, the atmospheric pressure compensation can be blocked, or it can even penetrate into the sensor module itself. You can see it here at the bottom. If this sensor module gets wet, then the measurement will stop, so the device will not work anymore. In worst case, it will even get damaged. So in the industry, there is of course Gore-Tex filters used to prevent most of the moisture, most of the water. But since you know this also from Gore-Tex clothes, it prevents water of entering through the cloth. But if you have dust, it's still able to penetrate through Gore-Tex. So water, dust, or moisture in a molecular form will be able to penetrate inside. So an ordinary pressure transmitter of this kind of construction will not survive very long in an application, especially a storage application for milk or beer. And therefore, Endress+Hauser has developed two different types of technologies to prevent water of entering, especially the part of the sensor module. And a very common and well-known technology is the so-called contight technology of our metal membrane of the Delta Pilot FMB50 and FMB70. So as the name indicates, it's spelled wrongly because when this product was designed or developed, it's already about 30 years ago. So we didn't have so many native English speakers in the company, but the name survived for 30 years in the meantime. So this is a technology which is really reliable, especially for hydrostatic level applications. And recently, okay, meanwhile, it's also 5 years ago, we have also extended the Cerabar PMC51, so the ceramic sensor module, with an additional contight technology to make sure that the ceramic also resists in such critical applications. What you can see here is the setup of the contight sensor with the metal membrane. So you see the metal membrane here, which is in the process. Then we have the piezo-resistive sensor chip, the sensor element, and we have at the back side of the sensor an additional membrane. So it's a kind of two-membrane transmitter. This additional membrane is only used to prevent water of going into this little hole here and flooding the sensor. On the right side, you see the schematic view. Here we have the two membranes, the pressure from the process, the atmospheric pressure coming from the backside, and in between there is our pressure sensor. Very reliable. We have a lot of devices in the market, several million devices installed base, and there are devices coming back after 30 years of operation and still in good condition. So a really reliable technology for applications when it is cold. So yeah, as I mentioned, the contight technology of the Delta Pilot FMB50 and 70 is of course the main benefit is its complete water resistance or condensation tightness, but we can also reduce downtime for example process changes, because the recovery time after temperature shocks is extremely good. We have the sensor very close to the process, and there is always a temperature sensor also built on it. And with this temperature sensor, we are able to detect temperature changes from the process very rapidly, and they can be immediately compensated. So that's an additional function of the Contite technology. We use a Hastelloy membrane, which has a better corrosion resistance, especially against cleaning media. And also, of course, like all our products which we use in hygienic applications, we have the full hygienic compliance. First of all, the hygienic design criteria of 3A and EH are fulfilled, but on the other hand, also the materials which are used comply to the FDA standards and to the European Food Regulation 1935/2004. Yeah, the 0-point stability and the long-term stability are also very, very good, because we talk about hydrostatic level measurement, which means a little change of the long-term or the 0-point stability will have an effect on the level reading. And especially in small tanks, this can have quite a few percentage of impact. That's why the devices are tuned especially for level applications. You can, of course, use it also in pipe pressure applications, but typically we go into hydrostatic level applications with these devices. Yeah, accuracy, of course, we are especially with the premium device, we have a high accuracy of the sensor, and in addition, also the electronics has an internal temperature compensation, which brings us also a few percent of additional accuracy on the whole range. So the ceramic, on the other hand side, is using a different technology. Here on the left side, you can see how the ceramic basic module is working. So we have a thin ceramic membrane and the sensor body. These two components form a capacitance. This is an oil-free sensor, so we don't use any filling oils. And you can imagine if for the atmospheric pressure compensation, if moisture would enter here into this little gap between the electrodes, it generates immediately a shortcut. And excuse me, to prevent this, we have developed a very extensive installation here to absorb all the moisture which might penetrate into the sensor. A so-called dehydration module is used, which has different functions, but the main function is to absorb moisture, whatever goes into the sensor. And this is the PMC51. And the benefits of this device is, of course, also a very good corrosion resistance. We have a self-monitoring function, which is unique for the ceramic sensor. So as soon as a ceramic sensor is flooded, for example, from the backside with water, or it's damaged mechanically, the device will immediately recognize this and send out an alarm. Ordinary pressure transmitters with metal membranes, they have an oil filling, and it takes some time until this oil is leaked into the process, and sometimes it takes several days or even weeks until a broken sensor is identified. So the advantage of the ceramic is that it's immediately reacting to any mechanical or electrical damages. Also, a big advantage of the ceramic is the full vacuum resistance, due to the fact that we don't have an oil filling, and oil typically tends to boil under certain vacuum conditions. We can go with the ceramic down to the absolute vacuum. So this means 0 bar or 0 millibar absolute. And of course, ceramic is much more robust than metal membranes. So with the ceramic, we go also in applications where we have fruit pieces, for example, or a frozen ice applications. All this is not a problem with the ceramic because it's very corrosion and abrasion resistant. Also here, high accuracy and repeatability are important. First of all, to come back to the production process after the cleaning cycle, but also to make sure that for hydrostatic level applications, you have the needed performance. The 0-point stability and the pressure shock resistance of the ceramics is unbeaten in the industry. So this technology is very reliable. Pressure shocks up to 40 times the nominal pressure range can easily be survived. So as mentioned, for these contact technologies, either the ceramic or the metal membranes, you can use them mainly in applications in the milk and in the beer industry. So the fermentation or maturation tanks, soft drink applications, also storage tanks where permanent low temperatures are present, but also sometimes in potable water applications, especially in the area around the equator. So areas where you have typically high humidity in the air, they generate also quickly condensate. So these are the applications to use an contact technology. Besides these already presented contact sensors, we also have further types of pressure sensors in the portfolio. The classical and the most economic technology is the piezo resistive sensor. This is the one here on the left side. It's a relatively small sensor design, and it has a metal diaphragm and an oil-filled capillary. So you can see here on the schematic view, this is the membrane. Here we have the oil-filled capillary, and here at the back there is the piezo-resistive element. However, having the piezo-resistive element relatively close through the process means we are also restricted in the temperature range. So these devices typically go up to 130 degrees. Long-term, more than 130 degrees would kill the electronics or the sensor module. Then you have to go for another technology, which is the diaphragm seal technology. We use also a basic sensor construction as on the left side, but we have much longer capillaries, and we use a kind of adapter concept to adapt to different process connections. So this is the diaphragm seal device. These devices are very common in the food and beverage industry. However, normally the temperatures in the process don't exceed 100 degrees because most of the media processed in food and beverage are boiling at 100 degrees, and this is typically not wanted. So the PMP51 is the first choice. We offer also different types of process connections here, and only if it's needed to have a very special process connection or an application which has higher temperatures than 130 degrees, then the diaphragm seals should be used. So they are more expensive, and they also have not the same performance level as the compact devices in terms of accuracy. Yeah, just to summarize, the 4 different technologies. So this is the basic model, which suits most of the applications, pipe pressure applications. You can use it for steam, for water, for air, all the utility applications. We offer also threaded connections here. So very universal device. The diaphragm seal you use when you have high temperatures. Above 130 degrees, you can go up to 400 degrees centigrade by the use, for example, of capillaries. And we have an extremely high variety of process connections. Also different membrane materials like tantalum or hastelloy or monel, etc. are available. And the two contact devices, the metal device with contact cell and the ceramic device with contact cell, they offer, of course, especially advantages when it comes to hydrostatic level measurement, or when you use the ceramic, you can use it also in vacuum applications, or you utilize the self-monitoring function. Now I'm coming to the point level applications. There are various products available on the market based on different measuring principles for point level detection in food and beverage applications. Basically, three technologies have proven to be most reliable. So this is the sensors based on the tuning fork technology, which you can see here in the middle, and conductive and capacitive devices like on the left and on the right side. So the tuning fork is an invention of Endress+Hauser. This technology was developed in the 1970s already and made its way through the decades. Today we have an installed base of more than 10 million devices out in the market in all different types of industries, not just in the food and beverage, but also in the chemical, oil and gas, and in the mining industries. This type of sensors are used to a high extent because they have proven to be really reliable and safe. So, and why is that so? First of all, it's a plug and play device, so there's no calibration needed. You put it into whatever kind of media and it will work. Also, the mounting position is not important. So the installation from the bottom is possible as well as from the side or from the top. We have an active measuring system, so it's not like a float switch, for example, which is a passive device. Here, the sensor function is permanently monitored, and by the use of our new heartbeat technology function, you are able also to monitor if the device is getting corroded. Mechanical integrity is also of big importance. It's a fully welded stainless steel device, so the sensor, the process connection, and also the extension tube, they are completely made of one piece of metal or welded to each other. So there are no additional seals, no moving parts, and that makes it also very robust in the industry. Also, no plastic parts which may fall into the process are used. So if you have a broken membrane or a broken sensor, for example, the fork, one of the forks is broken down, it can be easily detected in the process by the use of a metal detector. But most important is that it's a completely independent system. So build-up doesn't play a big role here as long as both parts of the fork, so both tunes, are free and not covered by the medium or by the build-up. It will still measure very reliably. Also, the media properties, may it be different conductivities, oil or water-based media, or the different viscosities, don't play a role. Air bubbles and foam are not measured or not detected by the system, so we detect the pure liquid level. And also external vibrations don't affect the measurements, like also turbulences or extreme pressure or temperatures in the process. Here is a typical application. We have here a beer application in a storage tank. At the bottom of the tank, you see the instrument installed in a Varivent housing. And the advantage of this solution is that the instrument is only recognizing the level, the liquid level, and if a little bit of foam would be present inside the pipe here, the device would not detect the foam. So you can be certain if the device reports empty, there is no liquid phase anymore in the tank. Yeah, but there are also other technologies, like, for example, the technology based on the capacitance technology. This is a very common and cost-efficient solution. The device is based on a sensor construction with a plastic cap. Typically, this is made from PEEK material. The electronics evaluates the capacitance between the sensor electrode and the grounded sensor housing. So if medium is present in front of the PEEK electrode or of the PEEK cap, the capacitance will change, and the electronic indicates this via its switch output. We have implemented this technology in our LiquiPoint FTW23. Like many other suppliers, offer also the similar kind of construction. However, if medium conductivity is not stable, for example, between processing and the cleaning phases, this may lead to false point level indication. Also, if buildup is left on the sensor, this may affect the capacitance measurement and could cause wrong indications. So that's why typically such devices are used in applications which have clean media, water-based media like water, milk, beer, and media which don't have a high viscosity. With the enhancement of this capacitance technology with the LiquiPoint FTW33, we have tried to eliminate these failure causes. First of all, we have implemented an additional measurement electrode. So we have a multi-sensor technology here. So it's on one side, we have the capacitance measurement, but on the other hand side, we also use a conductivity measurement to compensate and to identify the conductivity of the medium. With this additional measurement, we are able to adjust the device automatically to whatever medium is used. So it can be conductive, but also non-conductive medium. We also have improved the sensor design. As you can see here, it's a flush mounted design. So for example, you don't find any PEEK cap. We have very small electrodes which are insulated against each other by the use of PEEK rings. And this offers us the opportunity to use this device also in applications where pigging is done, or where you have a scraper inside of a tank. And also the effect, like in the yogurt production, very often it happens that the PEEK cap is destroyed because the frozen fruit pieces fall on the PEEK and the plastic is ripped off or broken. And normally it's difficult to find this in the process once it's in. So here we have a flush mounted design which is extremely robust also when you have such kind of fruit pieces in the process. We can also use it in very sticky or viscous media. Yeah, like here you see the fruit jam. This is a kind of mousse, or here honey. So this all works very well with the LiquiPoint FTW33. Just to summarize, so the FTW33 offers a full flush mounted installations, so pipes remain pickable. You can use it for water and oil-based media. No adjustment is needed because the device adjusts itself by the separate electrode. Here you can see how the sensor looks if it's installed flush mounted in a welded adapter that you can also get from us. Also, if there is buildup on the sensor, it switches very reliably due to the active buildup compensation. Yeah, and needless to say, we have a lot of different process connections for all kinds of applications, and also here the IP69 rating for the cleanability with high pressure cleaner is given. All our devices for food and beverage industry for the hygienic applications can be cleaned and sterilized in place, so they all survive for a short term the sterilization temperature of 130 up to 150 degrees. Here is a picture of the FTW33 with buildup on it. So if you dip it into the jam, like on the left side here, and you remove it again, the device will switch back to the empty state because this residue left on the sensor is not considered as level. Same also here when you have mayonnaise. So the segmentation for the food and beverage industry for the most common sensor technologies. So the pure capacitance devices, they shall be used mainly in applications where you have conductive water-based media. The liquefant, the FTL33, for example, but there is also other devices with the same sensor technology you can use in most of pumpable media. Only if the medium becomes really sticky and really viscous, then you should use the FTW33 for these special applications. So from my perspective, for the basic applications, use this one. It's of course the most price attractive solution. If you are facing a challenge of buildup or of high viscosity, you can use the other two solutions. Here is a little overview. You find this also in the handout when you download it from the portal, which device supports which media, like on the left side, the FTW33. This works in all media from water-based to sticky and viscous media, and also media like sunflower oil, which are completely non-conductive. So device works perfect. Honey, peanut butter, ketchup, mustard, everything is possible. The vibration fork technology works also very well in different types of conductive and non-conductive media. However, if the media becomes too sticky, the viscosity is too high, you should go for another technology. And as mentioned, the FTW23, the device with the peak cap, should be used only in applications where you have clean water-based process medium. What you can see here on the picture is also our devices with welding adapters. So you can use the same welding adapter for all three types of devices. So this is the 3/4 inch technology with the flush mounted O-ring. So if you try with this one first and find out it's probably not suitable for your process, you can replace it by one of the other two devices. So that's possible without changing the process connection or the welding adapter. We also have a new assembly that we offer especially for narrow pipes. It's a solution that you can use for applications in 1 inch up to 2 inch pipes. It offers a completely flush mounted installation of our sensors. So without any air pockets or without any recess where probably bacteria can nest. So it's very easy to clean, and you can either weld it inside the pipe into the pipe, or we offer also for retrofitting a clamp version. Here you can see two pictures. One is with our pressure transmitter, and on the right side you see the same with our FTW33. This is the clamp version for retrofitting. So a really flush mounted installation, easy also when you have an application where you want to pick the pipe. So all ANH devices which have an M24 × 1.5 process connection fit into this assemblies. So now I'm at the end of my presentation. So it's already 45 minutes left. Are there any questions on the presentation?
Thank you, Ralf, for this. Yes, there are some questions. Maybe when you could give a little bit information about foam detection, foam measurement. There was the question was, when you have a FMR 62 installed, and would it be possible to detect foam or is it possible to give information if foam will arise in this application? Even the application is supposed to not have foam, but sometimes, you know, in food industry, the applications, they have foam. So maybe if you can give some words about how to detect foam or how to get the information of foam in applications.
Okay, I'll go back to this slide. So here you see the typical devices.
There's no sound, Ralf. Wait, again.
Hello, hello. Can you still hear me?
It's good. Okay, it's good, good.
Okay. So this is the overview of the different continuous level devices. The capacitance probe is not affected by foam at all. It measures the foam, and the foam has a little impact on the accuracy, but the sensor still measures very reliable. When you have foam and you use a free space radar, it depends very much on the type of foam that you have in your process. For example, if you have a high dense foam, like in yogurt production, for example, and you have an agitator and it generates foam, this foam has typically a very high density, and a radar signal will be reflected by conductive foam. Yogurt or also milk applications with a conductive medium, it means that in worst case the device will not see the liquid level anymore, it will see the foam level. If you can accept this, it's not a problem. But if you want to see the real, let's say, liquid phase, the liquid level, then the radar is probably not the right choice. If you have light foam, like beer, for example, and it's not too thick, because what happens when you have foam formation, it also absorbs the radar beam or the radar electromagnetic waves. Then there might be a case where the device will not see any level anymore, so it just loses the signal. This happens every now and then. Typically, this happens in the applications with non-conductive media, like oil applications. So if you have, let's say, edible oils, then this might be an issue. We have a lot of different algorithms which shall prevent to lose signal, but nevertheless, in a very heavy application with a lot of foam, this may occur. So that's why, as a last resort, the guided wave radar can be used. The guided wave radar is much more, we have a much better concentration of the energy along the sensor rod, and that's why not so much energy will be absorbed by the foam. So we have a better reliability in foam applications. From my perspective, what I know from the experience is, if you have, for example, milk or beer application, the medium is not very corrosive or abrasive, and in such applications, the best choice is still hydrostatic level, because also the densities are not changing, they are very stable, and that's why still the hydrostatic technology is commonly used. When we go into the oil applications, edible oils, but also applications where you have, for example, bulk solids, then the radar or the free space, the guided wave radar are state-of-the-art technologies, and they have suppressed most of the other technologies in this field of application. So in edible oils, either guided wave radar, or if the turbulences or the foam formation is not so high, also the free space radar is the current state-of-the-art technology.
I think we should as well mention that with the FTW33, you even can detect if you have foam. So if you are interested in the foam measurement, if you'd like to know if there's foam on my on top of my liquid, then you could use the FTW33. And I think, Ralf, there is as well a kind of solution business available to detect with the FMR if there is foam formation on top, right?
Correct. So
even with the evaluation of the envelope curve to check if there is foam, yes or no.
Right. So first of all, to answer the question regarding the FTW33, so the point level device, this device can be set up either from the factory, or you can do it on site by IO-Link, for example, or with a separate magnet which is delivered with the instrument. You can set up the device either for detection of the liquid phase or of the foam. In the maturation, in the fermentation tanks in the beer industry, the customers are also interested to see if the foam is rising, to prevent overspilling of the foam into the CO2 line, for example. So here you can use, for example, FTW33, or we have also a pure conductive sensor, which I have not shown on my presentation, which is also useful for foam measurement. And like what you mentioned, Matthias, the second foam technology to measure or to detect foam is with our radar devices. With heartbeat technology, we offer the possibility to monitor foam formation. It depends a little bit on the type of foam, on the density of the foam, and also on the conductivity of the foam, but it's possible to monitor, besides the level measurement of the device itself, to monitor also foam. It's possible, needs a little bit of setup, but as I said, we have Bluetooth connectivity with the radar devices, and this means it's relatively easy to set up the device for different types of use cases.
Perfect, thank you. Then there's another question. What pressure sensor would you recommend for a vacuum application? For example, in a juice deaeration system. So, vacuum.
Here the choice is relatively easy because, as I mentioned already, when we look at the application range of our pressure transmitters, just a second, I'm looking for the slide. Here we go. All these three devices on the left side are using metal membranes with oil-filled systems. Some of them have a few drops of oil inside, like the one here on the left side or the one on the right side. This one has a little bit of more of oil inside, and oil always have the disadvantage that it expands or contracts when the temperature or the pressure is changing. And especially when you have vacuum, the oil inside of these three devices will start to evaporate. Depends on the application, on the temperature, and on the vacuum itself. But a safe choice is always the ceramic technology, because here you can apply full vacuum and the device works completely without any problems.
Okay, and then we have one application in a chocolate factory. So you had one slide where you gave recommendations of an application chart, which instrument to use when. And the question is, it's a little bit tricky. Yeah, usually the chocolate should be liquid. So what is the application fit chart for our instrument? Is it then a liquid? Because sometimes it gets solid as well. So what do you take care on chocolate production when it comes to level and pressure?
Now you're talking about point level?
I talk about, in this case, yeah, not really about a specific instrument. I think you showed at one slide, you showed this chart where you said we clustered the instruments in different application fits.
You mean this one?
Yeah, this one.
Yeah. So, of course, porosity is always an issue. If you have chocolate which starts to crystallize and becomes brittle or solid when the temperature is going down, then you may have an issue in your process anyway, because you need to clean it either mechanically or with a high pressure cleaner. I would say, I mean, we don't recommend to use this one in such applications due to the stickiness of the material. I would also not go for the liquefant, because if you have a solid block of chocolate forming on top of or on the sensor itself, it will definitely affect the measurement. So it will recognize this chocolate. The best solution would be also here the FTW33, because even if there is chocolate available and in a solid state, you need to clean it mechanically. You will not damage the sensor if you use a brush, for example, or a scrubber to clean off the chocolate from the process. And if it's heated up again and starts to liquidize again, then it's also easy for the device to continue operation.
Yeah, that's, I think as well, that might be the best solution. You will have, if you follow the presentations on Thursday, when we talk about flow instrument, is the same. It depends always. It's always good to have an instrument which can work with both situations. And if the chocolates get hard, the important is that the instrument is not breaking down and getting damaged. That when it starts to get melt again, if the temperature rises again, that the instrument starts working again. That's the important thing. Okay, yeah. And then we have maybe as a last question, it goes more to the connectivity. Will the IO-Link instrumentation, will they give as well a 4 to 20 milliamp output signal?
Yes, for all of our IO-Link electronics, we offer also a 4 to 20 milliamp output signal, at least for the devices which are used for continuous measurement. For the switches, we don't have a 4 to 20 milliamp output because we don't have a continuous signal to transfer. But for the pressure transmitters, for example, and I just want to highlight again the upcoming IO-Link electronics for our high runner for the 50 series. Here we will have also an additional 4 to 20 milliamp output. It's a 3-wire output, so this means you need to connect 3 wires to get the device up and running. If you use that one with IO-Link, if you use the device without IO-Link, you can connect it with a 2-wire cables. If IO-Link is needed, then you need to go with a 3-wire installation. But it's just a different wiring. The rest remains the same.
Okay, thank you, Ralf. Then maybe you can go to the last slide. So I think we answered all the questions now. So we are at the end of the presentation. 3 minutes left. That's great in timing. I hope we could give you a little bit an idea about the new innovations, about the new instrumentations. The main thing we like to give you is the idea that we have the instruments for all your applications, and we have for each and every application exactly the right instrument. So it doesn't matter if this is a hygienic application, if this is an easy, more low-end application, or really a high accurate application you need, because it's something quality relevant for your process. So I hope you enjoyed this seminar, and I hope we can maybe see you as well on the upcoming seminars. The next one is, as I mentioned already, on Thursday, the 22nd of July, where we like to talk about the flow instruments in the food and beverage industry. And then the week after, on the 27th of July, we talk about temperature, and the 29th of July, we talk about liquid analysis. And all with the same slogan, and choose according to your needs. So select exactly what you need, and don't, let's say, pay for more or getting over engineered instrument in a low-end application. That's it from my side. Thank you very much for your time and for your interest. Whenever you have any questions, don't hesitate to contact your local Endress+Hauser organization. Go to our webpage for more information, or you can even contact Ralf or myself via email or LinkedIn. Doesn't matter. That's it. Have a good
download. Don't download the handout.
Say again.
Don't forget to download the handout, which you can find here in the portal. So you can find additional information. Yeah, please contact us should you have any further questions.
And as I mentioned, the recording will be available, let's say, end of this week. You will get an email when the recording is prepared and ready for download. All right. Then thank you and have a good time. Bye-bye.
Thank you. Bye-bye.